You're watching InTechnology, a video cast where you can get smarter about cybersecurity, sustainability, and technology.
I'm Camille Urquhart, host of InTechnology podcast, and I have with me Ken Urquhart from Zscaler. He's Global VP of 5G and Strategy and knows a ton of things about cybersecurity, as well as telco, as well as holds 3 physics degrees. So welcome, Ken.
Well, thank you, Camille. Good to be here, and thank you for inviting me.
I just want to pick your brain all about 5G. I want to hit zero trust because it's a big buzzword, although I think people are relatively familiar with what it means. I want to dig a little deeper and understand what that means with respect to protecting telco networks. I want to know what 5G is. I did a podcast, I think about a year ago, with Lee Phillips, where he described 5G and kind of walked through it, but it's been a while. So I want to know, what's new? How has it evolved? What are we thinking kind of moving forward? What kinds of use cases are we seeing? And how do we trust 5G? So that's a big mishmash of everything, but maybe we can start with you giving us kind of an overview of what it is.
To boil it down, the simple thing is fiber optic speeds transmitted wireless. But there's a whole lot more going on underneath. Typically, when you go from 4G was really about high-quality audio streaming and really high-quality pictures. That enabled the Spotifys of the world, that enabled the Airbnbs of the world, where for the first time, I think you had a telco generation disrupting businesses because of these, what seemed like nice innovations actually drove quite a bit of disruption while generating multi-billion-dollar new industries. And we're trying to do this again to go to 5G, but there's a lot of stuff going on under the hood too that are there to make this happen. One is a desire to cut down the amount of power consumed. 4G consumes a lot of power in comparison to 5G. 5G's target was to try to get the power consumption of devices to run the antennas down by as much as a factor of 10. I'm not sure we're seeing that, but at least it was to get the power levels down to make sure you could do things like power up a device using a 10-year lithium-ion battery, which indeed we're now seeing. Things like vibration sensors, flow meters, with a 5G antenna and a 10-year lithium-ion battery buried in the ground with new piping with a small antenna sticking up to make sure it's not clogged or doesn't have a leak. These things exist today. One of the reasons is that we're going to have a lot more devices talking to each other. So there's this other thing to talk about 5G, which is it wasn't designed for us. It was designed for things. It was designed for IoT. It was designed for Internet of Things, for smart cities. It was designed so a lot of different devices moving in real time can coordinate their activity without harming people. So that's another aspect of it. And as far as security, it was designed to be much more secure than you currently have with 4G and earlier, based on what we can do to secure the network. That's also important. With 5G, the promise is the network itself is more secure against hacking and snooping. You're still on your own with your device and the workloads that device may connect.
You're going to have to say more about that. So I understand, like, my device could be hacked, or maybe the database or whatever that I'm connecting to.
Your communication of your hacked device back to the hacker is very secure. Silly way to look at it, but yeah, that's what you're promising.
But are you saying that networks were a primary attack surface previously, and now the network itself will be much harder to penetrate with 5G?
Exactly. If you go back and look, there was instances where in previous generation telco networks, hackers could lurk, watch the traffic, see what you were doing, steal your bandwidth, spoofing who you were on a foreign telco network. They'd say, I'm really this person in America and I'm operating somewhere in Europe, and treat me like I'm that person. When you're talking about saying, oh, I'm going to put 1 million devices per square kilometer, and I'm going to have smart cities, and I'm going to control robots and autonomously guided vehicles where people are around, you probably don't want them hackable through the network and then set on something they're not intended to do. Because that's another thing with 5G. The desire was to really increase the number of devices that could sit on an antenna. With 5G, they're talking about when they're set up in a square kilometer, you could put 1 million devices and also, more importantly, not see a lot of degradation in how much bandwidth you had or the speed of transmission. That's a big step forward. And then coupling that with lower power, you're on to something. You enable all the vehicles to talk to each other. You enable people to understand where they are, how they are. With the antennas in 5G, you need more of them because they typically, the higher speed means you transmit over a shorter distance. So by placing a lot more antennas in an urban area, you can get better triangulation of where you are. So they can also do things like tell where every device is down to centimeters instead of meters, down to inches instead of 3 feet.
I can see how that could be important when you're navigating, again, like autonomous vehicles. What does that do to the amount of frequency that's floating around us all the time? And what does that mean from a privacy perspective if I can now be triangulated down to the exact longitude, latitude where I'm standing in near real time?
That's a feature, knowing where you are. We do this every day. How many people navigate with GPS? The whole success of that, of navigation, depends on knowing where you are. When you talk about navigating inside a building, knowing where you are is going to be really important. Finding things, being guided to things. It's a trade-off that you enable by using the device. Now, with privacy rules, depending on the country you're in, you can say things like, don't track me, throw that data away. And there are rules in place that says to telcos, who are one of the most highly regulated industries on the planet, is, okay, you're going to throw that data away because that's what you, as the owner of that SIM, want.
What do you think about when it comes to 5G? Because you've looked at all of these standards, or are you already just looking at 6G now? Are you done thinking about 5G?
For one thing, we've hit kind of 5G. And just to remind people, 4G LTE is actually between 3G and 4G. So we never quite got to full 4G, and yet a lot of people benefit from it. 5G, we're mostly 5G. We're also now talking about 5G advanced, which is also now called 5.5G. And we're talking about 6G. So is it going to be radically different? And the answer is no, it's going to be an evolution. And actually not as big an evolution as going from 4G to 5G. 4G to 5G had a lot of things under the hood people don't see. Things like a complete redesign of how the telco software that switches all your data pack. The architecture was improved, factored, so you had, rather than large monolithic chunks of code, you had modules that interoperate with each other over well-defined interfaces to make it easier to manage, easier to deploy, easier to scale. The shift from bare metal servers in a data center to the ability to use cloud. So you can now put telco cores. Think of it as the thing that switches all your packets and gets them from one device to another or from a device to a workload. That now looks more like a typical NT cloud workload. Or before, they were very carefully crafted monolithic chunks of code sitting on telco-owned servers. So in theory, this all makes it easier to secure, easier to maintain, easier to provide scale services.
Does that also mean that non-telco providers can provide or create sort of networks, whereas they couldn't previously realistically?
Yep. It used to be you had to go to a telco to get a 4G LTE network. You would rent one. You'd get a private one, which would be a piece of their larger network. Now there's nothing to stop you setting up an entirely private 5G network. Your IT department can, in theory, set up a private 5G network within your company to take full advantage. You own the SIMs, you own the bandwidth, you own the antennas, you own what is called the 5G core, the big switch that moves all your packets around wirelessly. Then again, you've got to now have people on your IT staff who know a lot about telco, antennas, frequencies, deployments. It's not like Wi-Fi. You can't just set up a bunch of antennas, turn them on, plug them in to your local intranet, and everything works. There's a little more to it than that.
Are there going to be, as part of 5G, more like distributed servers closer to endpoints that then communicate or process information?
Yes and no. There's still the idea of the big switch, the core, can sit possibly in another state. What you have is the data flows over the user plane. But one thing they did in 4G and 5G is separate control signals from the customer data, so it makes it much harder to attack and makes it much easier to manage. So while the control signals, when you dial a number, when you want to connect to an app somewhere in the world, that can happen not in real time. It can take several seconds to establish that connection. Nobody gets upset. It's fast enough. When the data starts flowing, though, you want your app to be really responsive. You want your exchange of information to happen quickly. And so the data can stay local while the control setup, billing, everything else can sit several states away.
So are companies going to fundamentally use telco differently now? Do you think a bunch of companies are going to set up their own networks?
Remember, when you set it up, you're essentially going into the private telco business. You have to hire people who understand, even as consultants or even as subcontractors, the deployment of your antennas, the placement of them, the tuning of your antennas. How many people ever had to tune their Wi-Fi setup? You just keep adding Wi-Fi repeaters until you get enough signal. There's also, because we're sharing telco frequency now, and telco frequencies in most countries are highly regulated, meaning you've got to use your allocated bands. You can't go outside them. You can't interfere with others. So much so, when you're deploying a 5G antenna privately in a business, you have to get a specific frequency range for it. You have to actually set up a small device that interacts with the antenna and talks to the Federal Communications Commission, the FCC, and reports that antenna is up and running, its GPS location, and what frequency band it's using. And the FCC databases have to give you permission. Even if you're using what's called the Citizens Band Radio Spectrum, or CBRS, which is portrayed as the Wi-Fi of telco. When have you had to plug in your Wi-Fi base station and have it talk to a federal agency to get permission to begin operating? Well, this is part of the world we live in.
And why is that?
Because there's frequency is all divided up and parceled out. You can't just fire up an antenna and start operating, because you can interfere with someone else. Do you want to interfere with the police? Do you want to interfere with fire department? Do you want to not have a first responder able to locate you because your neighbor's broadcasting with an antenna in a frequency band they're not allowed to?
Just to jump back a little, why would a company or an organization want to set up their own private 5G network?
Let's talk about a factory. Right now, I run wires. Now, those wires, Ethernet cabling, they're contain low voltage. What does that mean? Well, in a factory, when it's high voltage and can kill someone, those cables are really tough. You can run over them. You can step on them. You can drop an axe on them. And they're designed not to be damaged, because if they are, there's a lot of risk to human life. Enter IP cabling, network cabling. Low power, not going to hurt you. So it gets a little plastic shell around it and they run it everywhere. You step on it, you drop something on it, you can damage it. They put them in piping. They try to do cable runs. But they still have to go everywhere. Easily damaged. Sometimes when you want to get a sensor to a running device, like a temperature sensor, a motion sensor, a vibration sensor to tell if the turbine's acting properly, you've got to have people finding their way to move the cables and walking in areas that are dangerous to be in. And they still have to do it. The other option is shut the factory down, we'll wire it up, and if we make a mistake, we'll have to shut it down again and try to fix it. Mostly they try to do it while it's running. Again, more danger to the individuals who have to work there. And again, the risk of damage. If you go wireless, you can do things like find the safest way to get to someplace, slap on the device. It's got a 10-year battery. you're done, and it's on the air with wireless. Private 5G is meant to be inherently more secure. So one of the biggest drivers for why would you want to use private 5G compared to anything else is security. Number one reason, the belief that its network is more secure. Who's going to decide to go to private 5G? 60% of the decisions we've made by the IT department, not the R&D department, not the executives, but the IT department will make that decision. Who's going to do it? 2/3 of the projected business in private 5G for the next couple of years is supposed to be just three sectors: manufacturing, transport and logistics, and resources.
What are resources?
Could be anything from energy exploration to mining.
Natural resource extraction. Got it.
Well, I think what we call primary and secondary industry. Again, because it's a large, dangerous place with a lot of equipment over perhaps a large area or a relatively large area. You need to know where your stuff is. You need to know how it's behaving. You need to know if your people are okay. You need to be alerted if there's a problem. Things like using drones to navigate large pipelines over huge distances when you don't have to send people out to do it. The ability to be able to tell if the temperature is okay over long stretches of water conduit, piping water. There's so many aquifers, piping channels through the deserts in the Southwest supplying much needed water. And how do you tell if everything's okay? You've got to go out and manually inspect. You could have an autonomous drone, 5G antennas, microwave links. They can extend up to 300 miles, and you can have machines running AI constantly just flitting back and forth, watching what's going on. When a sensor trips, you can find out what's going on without having to dispatch people and vehicles when it's 120 degrees. It's just a lot safer.
So, how full are the airwaves now? And has 5G substantially increased the amount of waves of frequency that are floating all around us?
Think of it this way. You can go find this on the FCC website. It'll show you the allocation of frequency spectrum for government, state and local, personal, industrial, and it's all carefully sliced up. Telcos spend a lot of money to obtain licenses to preferred frequencies. This is why one of the private 5G approaches is you spectrum from a telco for your private use. And then they say, we're not going to use it. You've got exclusive access to give you enough bandwidth, enough throughput. And there's things like part of the spectrum was borrowed from others. So 5G was borrowed a chunk of spectrum from what's used by space-to-ground satellites. And you say, what could happen there? The satellites transmit relatively weak signals to big antennas on the ground. You've seen these giant dishes. So they're very weak signal that they would then pick up. And it would always go from space to ground with a little bit of traffic going back up from other antennas. What's wrong with that? Well, beside it, we had part of the spectrum allocated to commercial jets, and they used it to determine how close they are to the ground by bouncing the signal off. Okay, now we give it over to 5G. Those devices in the aircraft assumed there would only be weak satellite signals falling and wouldn't cause any interference. When we allocated those bands to 5G, suddenly the antennas were broadcasting at much stronger frequencies that these little devices on aircraft weren't designed to handle, and the potential for interference, which is why you got this news report about 5G towers around airports had to be turned down or turned off or aimed differently because they didn't know what it would do to the aircraft.
What did it result in? What happened?
You had to replace the devices on the aircraft with devices more finely tuned to avoid the interference. It wasn't a big deal in the end, but there was a fight between the FAA and the FCC, a lot of discussion, a lot of people saying, hey, this is a problem. But it did mean that a lot of aircraft had to have a vital component replaced.
Talk to me a little bit more about what we expect in the future: ground to ground, satellite to satellite, off Earth transmission.
Remember, right now, you can buy, I believe, an iPhone 13 or an iPhone 14, and it will communicate with satellites. You can send an SOS from a remote location right now. Well, you've got antennas in orbit strong enough to pick up a iPhone's 5G antenna in orbit and establish a communication line to it. That's nothing short of amazing.
That is pretty stunning.
And there is, in fact, satellite 5G, which is a variant of the 5G definition. And that's also being rolled out as a standard, which means that there's a sufficient description that everyone's agreed on who makes antennas to enable you to communicate with satellites. And that's happening right now with 5G. You don't need to wait till 6G. 6G will maybe use different frequencies, which brings us to another interesting point. There's an idea that the higher G you go, the faster the connection, the better the connection, the more data you can push over the connection. And that means the higher frequency, because if you want to push more data, you go to a higher frequency of signal, so you can push more bits at any given length of time. You do that by going to a physically higher frequency. There's this little problem. When you go up too high, you start hitting what's called the terahertz frequency range. But here's a fun thing about terahertz. Yes, you can push a lot of data over. Fog can block the signal. Moisture in the air can block the signal. You can say things like, I can do terahertz over a couple of feet. All right, what does that mean? It means that in a building, I can eliminate all the wires. If I have to take a FEMA emergency communication system, I can haul it out in the woods, fire it up. I don't have to say, did everyone bring all the fiber optic cables? Do I have all the Ethernet connections? Where's the copper that I need to connect these components? You forget it. Take them out, power them up, turn them on, they find each other, and you're happening at fiber optic speeds. That's really interesting.
And that is 6G, you're saying?
If you get this idea, that's what 6G is all. It means I'm going to go up in higher frequency. Well, there is a plan to get into the sub-terahertz frequencies. Yes, that'll give us much higher transmissions, again, over shorter distances, subject to a certain amount of potential interference. But the other thing 6G is trying to do is use what you've got more efficiently. You tune the antennas better. Right now, you want a different frequency band on your antenna, you buy a different antenna unit. And you swap it in, and you have to tune all the parameters that communicate from that piece of hardware back to your telco core. It's a lot of work. We have software-defined radios, which theoretically lets you retune your antennas on the fly to different frequency bands. And that's one of the things they're investigating. The other one is using AI. Because if you can use AI to retune components of your system, instead of right now having to manually tune them by trial and error, which takes a long time, there you've got a much better system for communication. And when you're using systems that communicate over Ethernet with best effort delivery, instead of dedicated connections, you have to do more optimization. And again, AI is your friend. That said, the AI they're going to use is incredibly hackable.
Why is it incredibly hackable?
You can sit there with a perfectly programmed neural network. There are no bugs in it. Nothing funny happens. Then you can corrupt it using only the data fed into it. Case in point, we have antennas that they're experimenting with in 5G where you're using AI to optimize certain parameters. Like, how do you behave when I've got a lot of devices coming on suddenly? How do I change things to accommodate that most effectively? They tried with an AI. Then an experimentalist group took another AI and used it to modify the signal from a cell phone going to that tower and convince the tower it was overloaded and shut it down when there was only the single antenna talking to it. There's nothing wrong with the AI. It was how the data was being manipulated and sent into it. And nobody had to experiment. They just let the AI run till it figured out how to shut the tower down. Really easy. So yeah, you can poison AI, or you can poison the training data if you hack the database containing the training data. You can do things like manipulate the AI and install backdoors activated by certain inputs. It is a large area that needs to be investigated. And while you say, oh, does that make it really hard to use AI? Yes and no. You can also watch your AI and determine when it's acting funny, giving you the results that aren't useful to you. And you can swap the AI out in real time to a different kind of AI, which has different ways of being hacked. And you can just stay ahead of the attacker just by swapping out the AI back and forth. That is one quick way of doing it. And eventually, if all else fails, fall back on predefined parameters that let you keep operating, maybe not optimally, but let you keep operating. So it's not insurmountable, but there are some tricky ways of using AI against you.
Just to summarize, the way that AI can be utilized by 6G would be helping, say, a network or a machine quickly switch, as opposed to me going to my cell phone and deciding, like, is it Bluetooth or is it Wi-Fi right now, or am I going to cellular, which is going to be the fastest way or the best way to get a connection? And now we're probably talking more machine to machine anyway, but the device would be able to just figure that out on its own using AI software.
Well, that devices figure that out on their own today without the need for AI. Uh, AI is more of what happens when you've got a lot of people wanting to use your antenna at the same time. How do you retune and accommodate as many as possible? Because when you use an antenna, your phone negotiates with the antenna. And the antenna says, okay, you're going to stick to this little tiny slice of frequency compared to everyone else. And we're going to talk over that little finely tuned slice. And the phone beside you is going to get a slightly different, finely tuned slice of frequency to talk to the antenna. And that works great when you've got 10, 100, 1,000 devices. What happens when you're at the stadium and everybody fires up their phone to look at stats at the same time or tries to make a call? You know, with 4G today, you go to the stadium with, 10,000 of your closest friends. And if everybody tries to make a call, not everyone's going to get signal. Not everyone's going to get call complete. 5G, 6G would like to use AI in the radios to try to accommodate many, many more people than we currently can with how we do it today.
Okay, but the downside being you have essentially provided yet another surface area for attack.
It can be taken care of. It's just going to require some more thought and consideration and trade-offs. How do you handle it if you get attacked and you recognize that the AI is being messed with? What do you fall back? This is no different than having multiple redundant systems to protect against other things. We're making our solutions trickier, and that's great because there's that old saying, I believe Steve Jobs said it, that I will make my software at Apple arbitrarily more complex in order to provide my customers with the easiest possible user experience. So that's what we're trying to do, a better experience. And if that causes us to make it a lot more complex with AI, if it works, we'll do it. And if it means that someone can attack me in different ways, fine. You just have to deal with it.
So you look at AI and cybersecurity as a kind of a trade-off. I don't know if you're saying a trade-off, but it sounds like you're saying the more we use AI on our network, the greater the potential for cyber threats.
It's just different. Look, if you don't want to be hacked, turn all your devices off and cancel all your online subscriptions. You won't be hacked. At least not direct. Someone you deal with who uses them may be hacked, and then you're indirectly affected. It's how much risk do you want to take on? You know, identities are stolen in the millions every month. And for most people, it doesn't affect you anymore. You may get a new credit card. You may get a new bank account number. But for most people, it's an inconvenience, not an insurmountable destruction of their personal wealth or their family. It's not as bad as it could be. Not saying it's nothing to worry about, but it's certainly a lot easier to handle. We all are kind of attuned to it. You're going to get hacked. Okay. How fast do I recover? And it's pretty darn fast compared to how it used to be.
So resiliency has been dialed up sort of as we learn more about it, and the likelihood of it goes up.
Being able to operate securely in an environment you can't verify is secure. That's how I've come to say it.
Ken, what is zero trust? Can you define that?
Yeah, it's being able to operate securely in an environment you can't verify is secure.
You basically can't verify any environment is secure, right?
Again, it's how much effort you want to put into it. And in this day and age, we outsource, we partner, we get things from third parties all the time. There was a famous hack at a large organization. I believe their HVAC person brought a laptop in and said, "Hey, can I connect to your local Wi-Fi so I can do some reporting?" And they said, "Sure." And he went on there and he uploaded a virus across the big company's networks and ransomware from what you least expected. When you have zero trust, the idea is you can hook up your stuff, you can have partners hook up their stuff, and you're not going to cross-infect one another. You can operate securely. And even when you're communicating with your partner, the information exchange can proceed without the fear of cross-contamination. You cross multiple networks to do almost any business today, and you can't verify they're secure. It really is down to everybody looking at each other and saying, no, I'm okay, trust me. So now we're down to this. NIST has, the National Institute of Science and Technology, has published this idea of what does zero trust mean? And it means basically 5 things based on 3 foundations. The 5 things mirror what we want to do, which is me, the user, want to connect my device, let's say this laptop we're talking to each other on, over some number of networks to connect to a workload to do something useful to me. So there's me, there's my device, there's my network, there's my app, and there's my data. 5 things. Before anything happens, the idea was, are you who you say you are? Who decides who you say you are? The enterprise, the government agency. It says, I'm going to make you authentic. I'm going to make you verify your identity, and I'm going to pick what you need to do. User ID and password? Sure. Multi-factor? Fine. Facial recognition, voice analysis, other biometrics? Fine. The enterprise picks, and you have to do those things before I'll say, okay, I kind of trust that you're you. And I may ask you at any time in the future to do the same thing again. If you do something that looks odd, or I just decide to do it to you. That's the price of admission. Okay, so I've now verified that you, Camille, are a user. Now, what about your device? I also monitor your device. Let's say I issue you the device and it's a Windows laptop from a certain manufacturer. Is that what's on the network? Is it running Windows? Is it running the version of Windows I expect you to have? Is the patch level where it's supposed to be? And again, I set the rules. And if those are satisfied, I say, okay, where do you want to go? And you say, I want to go to that app. And you don't care what network you're going. And I say, okay, fine. I'm going to go take a look at the app. Is that app what you think it is? If you said, I want to go talk to this Oracle database, I go, okay, fine. Do you have the right to talk to that database to do your job if you don't get connected? Oh, and I report you. If you're allowed, you, through that device, are allowed to talk to that Oracle database at this time of day when you're doing it from the physical location we think you're at. We look at the database and say, okay, so are you really an Oracle database? If you are, you're going to behave a certain way. You're going to have a certain ports open. You're going to exchange data with certain protocols, and you're only going to talk to certain individuals that we allow you to. If you're in the finance department, the finance Oracle database should not be trying to poke at the engineering GitHub and try to copy source code. That's a good indication there's something funny going. So let's say, okay, you're behaving like an Oracle database. Camille's allowed to talk to it. All right, we connect you. We choose the network connection, and we stitch together a special kind of connection so it looks to you and your device like there's just you, the Oracle database, on a private, isolated network, and you talk to it. and you exchange the data you need to exchange it. When it's done, that connection is severed. That's a lot of work. So there's these three foundations. One is the governance that says, are you with that device allowed to talk to that workload to do certain things? So we have a governance layer, a lot of rules. That alone solves a lot of problems. It means you as an individual can't go poking around at other stuff. You can only see the things we as a company believe you should see. If you're in finance, yep, you've got access to these finance systems. You're not going to see the engineering database. You're not going to see any of the build system. If you're an engineer, you're not going to look at the HR systems except the ones you're allowed to look at to find and possibly modify data about yourself. And then the data exchange. That's going to be fully encrypted, and we're going to look at 100% of the packets to see that nothing bad is getting out or nothing good is getting out, like personal information, company secrets, but nothing bad like ransomware is getting in. And then if you've got the governance layer, you have the orchestration and automation layer, because all this is a lot of work. And you can't be so you as a user have to do all this. We do it for you. I'm talking to you right now over my company's cybersecurity solution, which is Zero Trust, and I don't notice it. You don't notice it. You didn't have to do anything to notice it. And yet all of our traffic is being inspected. So my laptop is not trying to send secret company information out, and you're not trying to send me ransomware.
And you're in a hotel and I'm at home. So neither one of us is behind the perimeter or through access security.
And that's the whole point. Who's behind a perimeter anymore? Where's a data center? The answer is there's a lot of them, but you don't necessarily own any of them. You're renting space. And the final thing on the three foundations is monitoring, because you got to collect all that data and look at it in real time. My company's system parses 1 trillion pieces of metadata per day to make sure everything is going okay.
Yeah, tell me a little bit about how Zscaler does this. You have something called a Zero Trust Exchange. How does that work? Described it at a high level, but
That's the thing that says, are you allowed to do what you want to do? But it's also the global network that watches and makes all connections for you. At its simplest, think of it like it's the old world where you would have a switchboard operator. Long ago, you had to pick up your phone and it would connect you to a human who would ask you who you were calling, what number you were calling, and they would manually patch a connection for you to the other person. And then their other person's phone would ring and they'd pick it up and the connection would complete. And when it was done, it'd be taken down. And this is what we do now, is we verify, we have this machinery that will verify who you are based on the customer, the enterprise or the government, and you being the user. We'll verify it's you. We'll then verify your device is behaving like your device should be, that possibly you're geographically where you should be, or if you're not, to say, you're on a business trip, you're doing this, you're doing, and this again, this is the enterprise, our customers decide what's going to be checked on. We're like this very obedient guard dog. You tell us what you want done, we'll do it. You tell us the rules you want, you tell us how strict you want to be, we'll take care of it. And as invisibly as possible to the users and to the customers and to the partners. The average company who is using the older ways often has, I think I saw a number, 70 or more individual solutions all interoperating to provide cybersecurity. That means 70 plus patch levels, watching 70 plus different feeds, configuring 70 plus different devices, making sure they interoperate, and a patch could kill the interoperability along a chain where you're passing all your data through to make sure it's safe. It's the old world. And the other one is this implicit assumption we will detect an attack after it's happened and then remediate, which is the most expensive way to do it, rather than stopping it from happening in the first place. My company, Zscaler, took the approach of stopping it before it happens, not building this entire machinery designed to catch it after it's happened and fix it, rather stop it before it happened. So we have one oil and gas customer who had up to 300 ransomware attacks a week. They were caught, they were prevented from proceeding, but they had to re-image the laptops. And that means you had people busy across this entire global organization doing nothing but re-imaging laptops, putting in a FedEx shipper, shipping it back to corporate or some location. It gets erased, re-imaged, tested, put back together, sent back by courier, and someone was able to operate again. We dropped that number to almost zero when we were installed. Why? Our approach is don't let it happen in the first place.
People have been hacked for like a couple of years, I think is the average, before they're even aware of it.
Yeah, that's just it. Oh, not even 18 months. Sometimes in mission critical, could be 9 months. Yeah, that's way better than 18 months. But how long do you have? Let's say if you're at a military installation and they say, yeah, if we get hacked by a foreign power, 9 months. Woohoo! You don't want it to happen in the first place. And that's really what Zero Trust was designed to do. Don't let it happen in the first place.
Ken Urquhart, Global Vice President of 5G and Strategy at Zscaler. Thank you for explaining Zero Trust, 5G, how it's moving to 6G, how it uses AI, some of the cybersecurity risks that we're going to be seeing because of that and that we hopefully are able to overcome, and explaining how Zscaler's Zero Trust Exchange works at a high level. Really appreciate the conversation and your time.
Oh, thank you, Camille.
Never miss an episode of InTechnology by following us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.